Alright, so I'm just going to go ahead and use one of our problems that we were assigned out of class to do to kind of explain what we did this unit. So this problem was about park rangers who say to estimate the weight of a bear, you can use the neck girth, which is the distance around the neck of the bear. And they gave us some data of bears that they collected, and they have neck girth and weight in the table. So we have two variables here. One is the explanatory and one is the response. The explanatory is not always on the left, and the response is not always on the right. So you have to look to see which one is the explanatory and which one is the response. So to determine which one is the explanatory, you want to think about which one is going to influence the other one to change, and also think about it's simple to think about which one kind of needs to come first for the other one to occur. So in this case, they told us that one way to estimate the weight of the bear is by measuring the neck girth. So in a sense, neck girth would need to come first. It's what we think explains the weight. So neck girth is actually the explanatory, so it's okay in order here. But once again, don't always expect it's in order. You want to make sure you identify which is which, because the explanatory is going to go in L1. So I already went to Stat and Edit, and I put my data in. Remember, the explanatory is always going to go in L1, and the response variable will go in L2. And we need to create the graph, so remember to go to second, y equals, enter to turn your stat plot on, enter again to make sure it's on, and then it's already set up to be on a scatter plot here. That's the default graph, so you can just go ahead and hit zoom 9, and you'll see your graph. And so when you create your graph, remember you need to create basically an L-shaped graph, create the general trend of what you see in the calculator. It doesn't have to be precise by drawing an entire scale, but you do have to draw the min and the max on each axis. And you have to also put what values those are, what values the min and max are. So to do that, you want to make sure you know those values, so you can go to Stat, over to Calc, go to 2var Stat to run the statistics for both variables. And when you calculate that and scroll down, it'll show the min and max for each axis. So notice the min and max for the x-axis are 15 and 32. So a neck girth of 15 and a max neck girth of 32. And then for the y-axis is 65 and 432. So 65 is the lowest weight in pounds, 432 is the highest weight in pounds for the bears that they observed. And then you want to go ahead and label both axes, just copy and pasting that text box I have there to create the other text box, which is weight in pounds, then copy and pasting that text box to make a title. So this is basically our general graph there for the neck girth and weight of the bears. So now we need to find the R value. So remember, to find the R value, you need to have your diagnostic on. Otherwise, your R value will not show up in the graph, in the graphing calculator. You must turn your diagnostic on. So remember, to do that, you go to second, 0. That gets you to the catalog. And you want to jump to diagnostic on, and to get to letter D's quicker, you can hit this X inverse button, which is the X to the -1 button. It has a letter D above it. You can just hit that button, it'll jump you straight to the letter D's quicker. And you can scroll down, turn your diagnostic on. When you get there, you need to hit enter twice so that it says done. So now you can go ahead and find your R value by going to Stat, over to Calc. And remember, we're doing linear regression, but it needs to be the second linear regression, not the first one. The first one's, remember, is for like algebra. It's set up in y equals mx plus b form. We want it to have the intercept, y-intercept first, and then the slope in the x variable. So you always do number 8. Always, 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 always do number 8. Alright, and then if you want to go ahead and store your regression equation in the calculator so that you see the line in the graph, you can put your cursor here. If you have the other calculator screen where it just says linreg with the open parenthesis, you have a little blinking cursor. Well, you're going to do this next step where that blinking cursor is. So you're going to go to vars, over to yvars, and hit enter, and then hit enter on y1, and then you'll have a little y1 there. So you want the y1 where the blinker or the cursor is, so that it's storing your regression equation in the calculator. And now you can go to calculate. And so we have our equation here with our y-intercept here. Our slope is our b. And we have our r squared and our r. So I'm just going to fill that information out over here. So I'm rounding the r value to 0.98. And I'm rounding the r squared to 0.95. And now my regression equation, remember that the y, you want to put a little hat over it to show that it's actually the predicted y values, not the actual y values. The actual y values are here. But remember the regression equation, which is also called the least square regression line, that equation is predicting what the values would be along that line, or along these, for these x values, but along the line. And we'll get the line here in a second in the calculator. So I'm going to go ahead and write the equation here. And use the equation editor real quick. So I'm going to go to insert symbols, but I'm really going to insert an equation and insert a new equation. So just to get the little hat over the y, there's just a little icon there you can do that with. So now we have y equals, well, the a value is negative 255. I'm just going to round to the nearest decimal place. So 0.4, nearest tenth, and then plus bx. So plus, because it is a positive b, if it was negative, I'd just put minus. Now that's going to round to 21, so I'm just going to leave it at 21x. Alright, and then my slope, notice the slope is always the value with x, so that is going to be 21, and the y-intercept here is negative 255.4. So now we need to describe the relationship in context. So remember that's going to include your 4 characteristics. So remember the 4 characteristics of a scatter plot that you need to discuss are the form, the direction, the strength, and whether or not there's any outliers. So you can go ahead and start off by saying, well, it's a linear form, right? The strength, remember to look at your R value for the strength. So your R value tells you how strong the correlation is. And we looked at the number line for that, so I'm going to pull that up so you can just reference back to that on looking to see what actual strength we have with a 0.98. You should know already, but just so you know to look at the number line for any R value. Alright, so just to bring this back up here, we can see that a 0.98 would be between 0.9 and 1, so that would be very strong. Very strong. So remember to use this scale when you're trying to determine or discuss the strength of a correlation, and make sure you're using the R value to discuss strength, not just what you think. Alright, so we have form is linear, strength is very strong, positive is direction, and then there are no obvious outliers here. So I'm just going to go ahead and write that in context. Write it in context. So I'm going to pause really quick so I can type that. Alright, so something like this would be good. So I put there's a very strong positive linear relationship between net girth of bears and their weight with no obvious outliers. And then you can go through and interpret each of those 4 characteristics individually if needed. So it would be something like this. So you would just need to mention something in context like this. Bears with larger net girths tend to weigh more. Now if you had to, if it asked specifically to interpret like the form, the linear form, or the strength individually, or if they wanted you to interpret the direction individually, you can by, here's my examples here, by providing information like this. So to interpret just the strength, the very strong strength there, you could say something like the actual weight of the bears based on their net girth will be very close to the weight predicted by the least squares regression equation. Because remember, the strength is measuring how close, get rid of my sticky note there so you can see the graph. how close the equation is to the line is to the coordinates, or the coordinates are to the line. So remember to, now that you put the y1 in the calculator, you can go back to graph. And remember, the strength is measuring how close those actual points lie directly on that line. So that's what you want to discuss when you discuss the strength, that the actual weight, which are, the points there are the actual data, are very, very close to the predicted weight, which is the line. Remember, the line is basically the predictions for net girth. So the actual weight of the bears based on the net girth will be very close to the weight predicted by that least square regression line. So that's how we're describing the strength. Now, if you had to individually describe the direction, basically we have a positive direction. So saying something like, it's predicted that as bears' net girth increases, so will their height. Because basically we're saying here, as the net girth increases, the height also increases. So you're just describing the fact that you have a positive relationship if it asks you to do that. And then linear form, basically to describe the form and to identify that it's actually a linear form, you have to mention that there's a constant rate of change. So notice here I just gave the example of saying that as bears' net girth changes by 1 inch, on average, the weight tends to change by a constant amount. Because remember, to have a linear form, that response variable has to have a constant rate of change to have a linear form. Alright, so that's all that part of describing. So now over here, we have to describe some other things here. So we have the value of the correlation coefficient. Well, our correlation coefficient, remember, is the actual name of the R value. So just describing or interpreting the R value is kind of very similar to what we did over here. We've actually did more than this over here. So just describing the correlation coefficient would just be describing the direction and the strength, because that's the only two things that it tells us. So you don't want to include more, because that's not what the correlation coefficient tells us. It doesn't tell us about the outliers. It doesn't tell us about the form. Now, it kind of tells us about form, but not 100%. So just stick with the positive direction and the strength of very strong. So it would look something like this. Let me pause so I can just make it pop up. Something like, there's a very strong positive relationship between bears' net girth and their weight. That is there in context, is telling us that the strength is there, it's very strong, and then it's a positive. So those are the two things we can get from the R value, the correlation coefficient. Remember, the other name for R value is just kind of like the nickname. The actual name is correlation coefficient. All right, now when we interpret the slope, remember, which is the 21, the slope tells us how much the response variable is changing for every one of the explanatory. So I'm going to pause while I put that. So I just put the little note here that the slope is basically how much the y changes for every one of the x. So remember, the y in this case is our weight in pounds, and our x is net girth. So it's predicted that weight of the bear, since that's our y, will increase, since it's a positive slope, by 21 pounds for every one, because notice here it's for every one of the x. So for every one, well, x is net girth in inches, for every 1 inch in net girth. So remember, for slope, it's how much the y changes for every one of x. So now to do the y-intercept, let me go ahead and put the note there. Alright, so notice I put that the y-intercept is what we predict the y to be when the x is 0. So it's what we predict the y to be, so what we predict weight will be when the x is 0 and net girth is 0. So we can say something like, it's predicted that the weight of the bears will be, well, what is the y-intercept? The y-intercept is negative 255.4. So it is predicted that the weight of the bears will be about negative 255.4 pounds when net girth is 0. But this interpretation is not plausible or logical. You can put logical if you like. But you definitely want to mention that because, and you can even say why, because it's not logical for a bear to have no net girth. There's no possible way. So I'm just going to say it instead of typing it, because it's going to take me a second to type it. But yeah, you can definitely say because, a bear can't have a net girth of 0. So something as simple as that would be fine. And they also can't have a negative weight. Alright, so in part 2 of this video, I'm going to talk about residual plots and residuals.